Hey Opties! Today we're going to be talking about linear tables, specifically using the slope-intercept form of a line. So let's talk about how you find slope from a linear table. A linear function has a constant rate of change, so it's also known as the slope. So here's a point to ponder. If the x values in a table have a constant change, so the number that you're subtracting or adding each time is the same, then the y value should also have a constant change, making a constant slope. But it doesn't always have to be that way. Let's take a look at example A, where we do have a constant change in our x and our y. So notice in our table we're adding 1 each time as we go down the line for our x's, and then we're adding 2 each time as we go down the line for y's. Well, remember, slope is the change in y divided by the change in x. So 2 divided by 1 is 2. This 2 divided by this 1 is 2. And this 2 divided by this 1 is 2. So 2 divided by 1 is always 2. That's what the point to ponder really means. A y change divided by the same x change every time is going to be the same number. So for this example, our change in y was constant add. Our change in x was a constant add. So a constant add divided by a constant add is going to be a constant rate of change. Here in example B, we have a different scenario. Notice that we're increasing by 2, then by 1, then by 3 on our x's. For our y's, we're increasing by 12, then 6, then 18. So you might think, well, maybe this is not a linear table. Maybe this table represents some other kind of function because I don't have a constant add on both sides. But you have to check that it has a constant rate of change or a constant slope, not just a constant change for your x and y. So we've checked that over here. 12 divided by 2 is 6. 6 divided by 1 is 6. And 18 divided by 3 is also 6. So notice your slope is constant. Your slope does remain the same. So this does represent a linear function. And our change in y was non-constant, a non-constant add. Our change in x was a non-constant add. And we still had a constant rate of change. So there's an example of that as well. For slope-intercept form of a line, we need to find the slope and the y-intercept. So here's how we're going to find y-intercept given a linear table. First of all, a y-intercept, which is b in slope-intercept form, is the y value that occurs where x value is 0. Here's our point to ponder. In a table, the y-intercept can sometimes be easily found because your x value of 0 is already in the table. And there you would just have to look whatever y value goes with that x value of 0 and you're done finding the y-intercept. However, if your x value of 0 is not already in the table, you need to find the slope and apply it, meaning using the slope to backtrack to find where x is 0, and then you can get that y value. So let's look at example C, where x equals 0 is already in the table. So we see our table, x is 0 and y is 2. So at x equals 0, y is 2, therefore telling us that b, or the y-intercept, is 2. Example D is different. We do not have a 0 for our x value. So we have to find our slope, which is 6. This was the same table that we had above. So remember, our slope is 6. And if we look at this x value of 1, we only have to backtrack once to get to 0. And then we can figure out our y value. So when I say backtrack, here's what I mean. Start at your point 1, 2. If we subtract 1, you'll get to 0. Well, that's your x change because you're subtracting something from your x value. What would your y change have to be in order to maintain your slope? Well, -6 divided by -1 will give you 6, which is your slope. So you can subtract 6 from your y value to figure out your y-intercept, which in this case would be -4 because 2 minus 6 is -4. So that's how you can find your y-intercept given a table where x equals 0 is not already given to you. Let's take a look at some practice with linear tables. This one is going to be where B is in the table. So number 1 says a robot is decreasing in speed at a constant rate along a path. So the fact that it says constant rate means constant rate of change, and that's how we know this is a linear table. The table below gives the distance d, feet, the robot was from a reference point at 1 second intervals from t equals 0 seconds to t equals 9 seconds. Write an equation in slope-intercept form that represents the relationship between t and d. Okay, so let's make sure we understand which variable acts like our x and which variable acts like our y. So the t is going to be x. Notice it's increasing at a constant rate, which doesn't always have to be true. But if you're thinking about a real-world scenario, typically your x is your thing that's increasing constantly because it's your independent variable. D would be like our y. Okay, so we're going to have some sort of equation in this form. Instead of y equals mx plus b, which is our slope-intercept, instead of y and x, we're going to have d equals mt plus b. So let's just keep that in mind as we're going forward. Now we need to find our slope and our y-intercept. Your slope is still going to be m, your y-intercept is still going to be b. And when we finish our equation, those won't be m and b anymore, they'll just be the numbers we find. Remember, b is in the table, so let's find b, and it always occurs where the x value, or your independent variable, is 0. So here we have t is 0 and d is 33. So this guy right here is b. B is 33. And let's think about the units. D is distance in feet, so that's going to be 33 feet. So what's this mean? It means that at the starting point, the robot was 33 feet from the reference point. Now let's figure out our slope. Let's find the change in y divided by the change in x. Let's look here. It doesn't matter where you go as long as you're just doing the points that go together. So you're not like doing 30 to 24 and then 1 to 2, because those aren't 2 points. That'd be like mixing up your points. So from 30 to 27, you're going to be subtracting 3. Remember, it says decreasing. So you would expect there to be a subtraction there. And then from 1 to 2, you add 1. So this will be our change in y. And this is our change in x. Now remember, we could also call this the change in d. And we can also call our change in x the change in t, or the change in time. So how many feet are you moving away from the reference point? And how much time does it take in seconds? So you're moving 3 feet away every 1 second. So -3 divided by 1 is -3. So that's -3 feet per second. And we know that distance is really not negative, but this negative would indicate that you're moving away. So let's complete our equation. D is the slope, which is -3, times t, plus our y-intercept, which is 33. So this is our equation in slope-intercept form that represents this robot situation. Our next problem is where B is not given to us in the table. So number 2 says, R&I Cookies charges an upfront order fee and hourly fee for services. The table below gives the money, $, earned over a job of 50 royal icing sugar cookies spanning 5 hours. Okay, write an equation in slope-intercept form that represents the relationship between t and the money. So the t is going to be our x, or independent variable, and the money is our y, or dependent variable. So y being our dependent, or our money, we're making a certain amount of money depending on how much time they're working. So let's go ahead and find the slope. So how much money are they making per hour is what the question is. So from 55 to 60, you're going to be adding 5. And from 1 hour to 2 hour, that's just 1 hour. So 5 divided by 1 is 5, and that's your M, or your slope. So it's not really that high of a rate. Either they're not paying themselves very much, or they're charging a pretty good amount of an upfront cost. So let's follow this slope and use it to find the y-intercept. I'm going to rewrite my point as a coordinate, and so we can backtrack with the arrows and the subtracting like we did earlier. So I'll do 155. Now, let's think, what are we going to have to subtract? We have to subtract 1 to get to 0. Remember, we want the x value of 0 to figure out what the y value is to find our y-intercept. So how can we change 5 over 1 to be okay if we have a -1 at the bottom? Well, -5 divided by -1 is still +5. So what we'll do is subtract 5 here. So 55 minus 5 is 50. So 50 is the y-intercept, and that's $50. So that's kind of a big startup amount. So you're paying $50 regardless, and then you pay $5 extra for every hour they work. So let's make this clear. The M is 5, and that's $5 per hour. And the B is $50. So you could also write this as the $sign on the 5, and then like that. So $5 per hour. So let's write our equation. Y equals mx plus b is slope-intercept form. But remember, we're not going to have y and x. We have to change those to the variables that represent the situation. Y is money. And this looks kind of funky. It may be that they would have D for dollars or M for money. M would be kind of confusing because it looks like slope. But just be aware that whatever that letter is, that goes for your Y. So your slope is $5 per hour. And that's for per every hour, so per that T. And we're getting $50 to start. So here is your slope-intercept form, where this $sign is a variable. All right, that's it for linear tables. See y'all next time.